I guess we'll get started. So I am Jen Rose Fitzgerald. I use she, they pronouns, and I am the coordinator for the Data for Social Impact Initiative. And the purpose of this initiative is to build capacity and connection among social sector organizations who want to use data to increase impact, promote more equitable outcomes. And so we're trying to provide some different kinds of spaces for folks to connect and think about and grapple with how can we collectively use data better for good, in essence, and very simply. And so one such space is what we are calling a data deep dive. And today is our very first one. So thank you all for being here. And just the purpose of this series is really to get some dialogue going and connection around the use of data, collaborative use of data. So by highlighting some innovative things people are doing with data collaboration in the St. Louis region. So today we're going to hear about some data collaboration efforts that are taking place around how to improve transportation specifically, but many of the principles apply to other sectors. So we hope as you're listening, you'll also think about like, how do these themes touch on your own work? Whether you're in healthcare, education, housing, or wherever your work kind of hits the ground. So that's why we're here. And a quick sneak peek at the agenda is basically quite simple, just a little intro and background to how we got here. We'll have a presentation and then a little Q&A. And at the end, for those who can stay for that last half hour, we want to just kind of broaden it out and have a broader conversation about data collaboration and how it hits the ground in other sectors as well. So that's the big picture. That's really what we're doing here today. Before we get started, however, I want to do a shameless plug for our survey. I'm going to drop this in the chat, and my hope is that you will just open it up and have it open in your browser so that at some point after the event, it's right there and ready for you to fill out. I know you all are data people, or a lot of you are, and you understand that these can really help us like shape our programming. So we would just love to hear your thoughts and how we can best meet your needs in future events. So I will do that. And in the meantime, I am going to pass the baton over to Bernadette Marion, who is going to introduce our speaker. So Bernadette, take it away.
Hi, thank you, Jen Rose. Hello, I'm Bernadette Marion. I'm the Director of Research and Development in the Planning and System Development Division at Metro Transit. I'm very happy to introduce Dr. Yao Erdu-Gyamfi. We call him Yao. We can all call him Yao. I'm very happy to introduce him. He works in the transportation field and in many fields, but I know him from working with East West Gateway, MoDOT, and St. Charles on the RISD project. He's going to talk a little bit more about that in terms of the data work that he's doing for these organizations. But here's what I want you to know about Yao, is that he has worked with us at Metro Transit as well. And what he has said to me is, hey, I have a lot of talented people working around me, but what I want to know is what is impacting you? What is impacting people on the ground? This is a person who can be doing anything. He has insights and intelligence and talents to be doing anything. But what he wants to know is what is impacting all of us on the ground. And that's why I thought he would be a perfect person, or we all thought he would be the perfect person, the inaugural person to our Data Deep Dive series to talk to us today. So thank you, everyone. Please ask many questions. I know he wants to hear from everyone. So please ask many questions about his presentation today and about his work and about anything he can solve for you, because I think he can solve anything. So again, thank you very much. And I am going to hand the baton to you. Yao, thank you so much for presenting today. Appreciate it.
Thank you, Bernadette, for the introduction. I hope I could solve every problem. Unfortunately, I can't. But I believe as we work together, we get closer and closer to solving the problems that we all care about. And thank you all for joining. I've had opportunity to work with a lot of agencies in the St. Louis region, and I love solving problems, especially in that area, because especially when it comes to transportation, they have peculiar challenges. Missouri is kind of, apart from, I think, St. Louis and Kansas City, the rest are pretty much, there isn't much of a problem when it comes to transportation, because traffic looks good outside St. Louis and Kansas City. So I definitely like working in these areas because there are different challenges that usually keeps me awake when I work in those areas. But anyway, I'll go ahead and talk about some of the things that I would want to highlight today. So as transportation engineers, we care about basically moving you from point A to point B in a safe manner. Now, however, the safety of motorists has always been a challenge, although this is one of our primary goals. Crashes and fatalities keeps going up. But I mean, especially for young adults, it's the #1 leading cause of death. If I look into the data I have for St. Louis, whenever there is a fatality involving an adult, I mean, a young adult or a teen, 75% of the time is a male. Whenever there is a motorcycle accident in the St. Louis region, 50% of the time it ends in a fatality. So these are big problems that requires us to work together, different agencies to work together to be able to come up with a comprehensive solution. So this, what I'm showing you right now is pretty much, I have a map that's showing all the crashes that has occurred in St. Louis between 2014 and 2021. As you can tell, pretty much most of the roads basically has some dots on it. That's a lot of crashes. Annually, we get between 30,000 to 48,000. Now, these crashes, the number of crashes has been increasing. I think for the past 3 years, it's usually been about 45,000 crashes within this particular region every year. The deaths or fatalities has usually been close to 200 deaths, which is pretty sad. The federal government's goal is to basically reduce this to 0. I really hope we can get there. We are currently close to 200, and that's just not good. 1/4 of the deaths are usually pedestrian crashes, which is also pretty sad. And as you can see, and I'm going to get my pointer here. Obviously, you can tell that this is a plot of the hour of the day of the week on my y-axis, and the hour of the day on my x-axis. And you can tell in the morning, we do have crashes between usually 7 to 9 a.m. There are a lot of crashes happening. And then also PM peak in the afternoon when you're coming from work. Most people are tired, and the crashes usually are way more during the PM peak. One more disturbing point is on Saturdays and Sunday nights, 12 a.m. When the first time I saw this data, I couldn't believe it. I was like, there's nobody on the road. Why do we have people dying this much? And once I cross-listed that with drunk driving and all that, it basically showed most of this is pretty much drunk driving. So this is still, safety is still a big challenge for us. Now, while we want you to be safe, we also want to be able to move people quickly, okay, from one point to the other. And of course, as I said earlier in the beginning, outside the big cities in Missouri, we usually don't have a big issue with congestion. Now, although people in Missouri may say, hey, traffic is really bad. I've lived in different places on the East Coast and the West, and I know the traffic here is nowhere close to those ones. But generally in Missouri, it takes about 1.5 times during peak hour. It takes about 1.5 times your normal commute time. So for instance, if it takes you 30 minutes to go from one point to the other, then during peak hour, it's going to take you about 45 minutes, which is not too bad. But that's another challenge we could improve. Now that changes completely when an accident happens. It could get worse. So safety, mobility, or congestion. Those are key factors that we want to address with transportation. Now there are other challenges that we have, a lot of them. For instance, motor vehicle registrations are going up, so we should expect that traffic is also going to go up. This is one of the plots that I was so surprised by, because every data I've looked at, 2020 there's a big dip. And then I look at 2020 motor vehicle registrations, and it's not changing much. This COVID hits, and yet we're still registering a lot of vehicles. And 2021 it kept going up. So we don't have the infrastructure. If things keep going like this, we may not have the infrastructure to support it. We do not have adequate public transport. And so, which means that a lot of people will keep acquiring cars and registering cars. You can't walk and bike everywhere. So these are all key challenges. And my approach to solving these problems is data. Take data, and then together with a set of tools that will help analyze the data, visualize the data, make predictions on the data, I hope we can be able to make better plans on how we can respond to some of these crashes, or be able to improve mobility in some of our cities. So let's start with the data. I'm going to give you kind of a history of transportation data, and where we were and where we are. So I'll probably start with like the late 90s and the early 2000s. This was a breakthrough. We had a way of basically looking at how fast people were moving on our roads. We use what we call detectors. These are microwave radar detectors. So we install them generally on the roadsides, and I'm sure you've seen that. This is one of those systems. It will be able to count the vehicles that are passing. It will be able to tell you the speeds of the vehicles. It'll be able to tell you how long they stay at a point. They are installed all over St. Louis, and the map you see on the left is basically locations that we have these detectors. So most often we keep them on the freeways or the highways. That's where generally, because when there is a breakdown, it affects a lot of people. So you will see all these detectors on the freeways. Now, if there was like a traffic jam, or there was an accident and it caused a long queue, these detectors will be able to pick it up pretty quickly. Now, the only problem with this is if there is an accident and there is no queue, then it can pick it up, because it has no eyes. It's basically a sensor, a detector that basically detects how long a vehicle is spent at a point. Okay, so it's good when there is congestion. It's good when the event causes congestion, but then when you don't have congestion, it can't really tell what's going on the road. Now, the good side of this is it's non-intrusive. It cannot see you. It only senses an object or a vehicle. So most people like it because privacy is not an issue here. So now the problem is that it doesn't have eyes. It can't see what's going on. And also it's expensive, so you can't really install this system everywhere. Now, because you can't really see what's going on, we went ahead by installing CCTV cameras. So on the left, I do have CCTV cameras across the St. Louis region. Now on the right, you see a video playing. There was an accident there. Now you can tell that there's an accident, but traffic, it's just flowing normal. There is no impact on the traffic state. So with this, the CCTV helps. Okay, so if there's someone at a traffic management center who's looking at this CCTV, they will quickly be able to know that there is an accident there, and then actually coordinate the necessary response to that event. Okay, so CCTV also came in. The only problem with CCTV is intrusive. Okay, so you can actually see people. Now, generally, for public view, we will usually compress the video so that you can really see people's faces. So you can actually, on the video, you can see people, but you can't really tell who is who because the video is compressed. You can't also see the license plate numbers, but before it's compressed, you can see everything. You generally can see license plate numbers. You can see people's faces. They are really high definition cameras, and they are pretty good. I mean, they have a pretty good resolution. Now, for my purposes, I usually work with these images. I don't work with images where you can see people's faces and all that. And also, if I want to store the data, I binarize the image. So what I do is I turn it into black and white pixels, like what you see on the right. So the left side is basically the video, on the right is what I store. I'm not really losing any information. I want to see the cars. I can process the vehicles later, but it helps you preserve people's privacy when it comes to this particular data. So CCTVs are good. The detectors are great. They have their limitations. The CCTV also are good. They also have their limitations. You can't install cameras everywhere. Okay, so you'll be able to monitor certain locations, but then there is a limit as to how much coverage you have. So I think maybe early 2000s, somewhere 2003, 2004, we realized a lot of people were using mobile phones. So we were like, okay, why don't we pull traffic data from people's cell phones? It's become big today. And as a matter of fact, there is just so much you can do with this data. What you see, I think, on the map is basically, for instance, a plot of people's locations on the map. I think, okay. Now, we can take this data and basically compute what we call the speeds or the travel time on every road segment, pretty much across the state. Everyone has a mobile phone. You sit in the car, you drive, we ping you, we get your location each time. And we can use that to know how long it took you to travel from one point to the other. Okay, now I know what you're thinking. This is, you're invading my privacy. I hope you, whenever you get onto Verizon or AT&T, you read your documentations, and before you sign things, you know that they're actually using your data. I don't do that. Basically, I go to, so there's a third party that we talk to who basically aggregates this data. So we have no access to your private information. Generally, they'll tell you for this road, this is how long it took for people to drive on. Okay, so there is no personal information there. So all I get is this particular road segment. This is the travel time. This is the speed. This is how many people were actually on this particular segment. Now it's good for us. We get the travel time across the whole state on most roads across the state, but it's intrusive. Okay, so the third-party vendors generally have, they are supposed to abide by certain rules that helps them preserve the privacy of the user. In a sense that when they push the data to us, all that is anonymized and the data is aggregated at a level that you don't actually have access to the private information. Most recently, probably a year or two ago, we've had access to one other data, which is really phenomenal. Is the connected car data. So if you're driving a car that's like 2021, 2022, it has this. The car is able to connect to the internet. It also has sensors on board. It can tell you the location of the car every 3 seconds, speed, how you're accelerating, how you're decelerating, the engine efficiency, fuel efficiency, how the engine is performing, and so on. Now, this is really good data. We can tell when people are slipping on the roads. We can tell when people are accelerating too much or people are hitting their brakes so much. This can help us a lot, especially when it comes to knowing where crashes are likely to happen, or if there's something going on on a particular road that's not good for drivers, or it's likely to create an accident. We can actually get this data. So in the St. Louis region, what you see on my screen on the left, the first is basically a plot of the locations of different vehicles. And this is only for an hour. So you can tell within an hour, I have enough data to cover most of the city. And this data comes to us every 3 seconds. So we pull basically your location every 3 seconds. And what we have in the middle is basically it was for one particular vehicle, and I'm basically plot the trajectory of the vehicle throughout the day. So we can tell when they weren't driving, when they were driving, where they went to, where they came from, and all that. Once again, these are usually provided to us by third-party vendors. There are ways that they go about trying to deal with privacy. So one way is pretty much they, instead of tracking you throughout the day, they will usually like track you for like 5 minutes and stop, and then come back maybe after like 15 minutes and track you again. They also do not provide us with like your information or anything about your car. It's usually your location and the performance of your vehicle. These are usually the car companies that provides us this data. GMC, Ford, Chevy, Cadillac, and Benz. They are usually the main vendors. If you have any of these cars, 2021 to 2023, you're really helping us and giving us data. I hope I don't scare you off, knowing that they are basically pulling your data. And sometimes, I mean, I think you can sign forms that they'll take you off this. But as long as your vehicle is connected to the internet, this data comes in. And I think within a day, we get over 20 to 25,000 vehicles being painted in the St. Louis region. And once again, as I said, there's a privacy issue. This is intrusive, and it should be good to figure out how to deal with the privacy issues here. Now, the connected data, it will tell us basically, one really important data we get is origin to destination data, where you're coming from and where you're going. Okay, so you can tell this is a zoomed out basically plot of the origin destination. So you can see some people going from St. Louis to Minneapolis, St. Louis to Chicago, Kansas City to Sioux Falls. But you can tell most of the journeys are within, like for instance, in St. Louis, you can see the ones in Kansas City. And if I zoom in, this is basically zooming into St. Louis. You can see all the trips that were taking place, and this is on a particular day. So you can see all the different trips that are taking place. It's good data. We will be able to know where people are coming from, where people are going to, and it helps us plan, put infrastructure in place to support the needs of our citizens. So it's really good data. So given all this data, our ultimate goal is, can we share this data with different agencies of interest? Okay, because if you look at St. Louis, there are different transportation agencies. MoDOT has roads that they have to manage. Okay, your city has roads that they also have to manage. There are MPOs, there are transit agencies. All of them come together to help improve safety, mobility, and all that. So it will be good to provide all of them with this data sets. And then we can then come up with a way of solving some of the challenges that we see in our transportation today. But there's a problem. The biggest challenge is that the data is just too big. So if you just look at the detector data, the first data I showed you, in a year, we get about 350 million rows of data. The probe one, the one that comes from the phones, we get about 6 billion rows of data every year. And we have about 10 years of data right now for that. Connected vehicle data, we only have 1 year now, and it's about 12 billion rows of data. So these are huge data sets. They're all in terabytes. And this is not all. We have like crash data, we have weather, we have other crowdsourced data. So those of you who use Waze apps, we get all that feed also. So it's huge. One agency cannot really, it's going to be difficult for just one agency to handle this data. So we have to find ways to think around this, this issue. If we basically put all this data together and give it to one person and say, hey, can you handle this? All these agencies are going to ask for the data from you. You end up with a situation like this. You're going to just stress this person up. People are going to be asking different questions. They are from different agencies. You don't want to do that. Ideally, what you want to do is you want to avoid this. Don't, you have to democratize the data. Everyone should be able to make their own queries. Everyone should be able to analyze their data. Everyone should be able to have access to hardware and resources that they can themselves manipulate their data, rather than having one person where everybody goes to kind of access data or request different data sets. So I call this data democratization, which is basically everyone within the agency having access to data sets that is not private, I guess. Now, it's not just the data, but also the hardware, because the data sets are so huge. You just don't want to spread the data set around. You want to keep them in one place and then use the same hardware or cloud provider to basically serve the people. And then software. Okay. So ideally, I would say, no, don't even download data. Have everything, all the software available to everyone. So democratize all that: data, hardware, software. And then I believe these agencies will be able to benefit from that and able to make pragmatic decisions from that. There is also another problem. So apart from the big data problem, there's also an integration problem. So just these 3 data sets that I'm showing you, there have 3 different vendors. TransCore will give you the detector. Here gives you, which is a mapping company, will give you the probe data, which is from the cell phones. And then Wajo gives you the connected car data. There are 3 different agencies. They all don't see I-70 the same way. One will spell I-70 with a dash. One will spell I-70 with no dash. Another will spell I-70, we'll call I-70 Interstate 70. It's so because they're different data, I mean, vendors, they treat the data differently, and sometimes it's really challenging to integrate it. Okay. Without integrating the data, though, there isn't much you can do with it. There's not much you can do with that data. So we need to figure out a way to integrate the data despite having different vendors providing this data. So the solution I usually propose is one ecosystem where you can store, integrate, and analyze the data. And also share it. Now, once you've stored, integrated, and analyzed, I mean, provided a way to analyze the data, you share your information, you share the data, and make sure you're also sharing hardware resources, share software resources. All these are shared. Don't just share data, but share the ability to analyze and also visualize the data set all in one ecosystem, without people having to take data out of the system. Because once people begin to take data out, it's very difficult to track privacy issues that will be breached. And so by having one ecosystem and then also masking so many things, but then providing an outcome that people can easily find answers to questions they're asking, it's most beneficial, I believe. So I think Bernadette mentioned this, Richie. This is what we actually built for the St. Louis region when it comes to transportation data. So it's pretty much a cloud-based system. It provides a data warehouse. So it's one place where all the transportation data set is stored. Now you can actually come there and then download data. You can also use the same platform to visualize and analyze the data. And also you get access to predictive analytics, which is basically leveraging AI to make predictions. So all this is in one ecosystem. Now, before I go into details, these are the key agencies that we're talking about. So there is St. Louis County and City, St. Charles, we have MPOs, we have MoDOT. Now, the challenge here was, for instance, when it comes to cameras, at one intersection, you may see 2 or 3 cameras. One is owned by MoDOT, the other is more owned by St. Charles. And why should we have 2 cameras at one intersection owned by 2 different agencies? Could we not use one? But because you have no way of sharing the feeds that comes in, basically everyone has to get their own camera and put it at the same intersection. Now, MoDOT generally will manage the highways, and the city roads would generally be managed by the cities and the counties. So there are cases where there's an intersection between a MoDOT road and a city road. And so the MoDOT will have your camera there, and the city will also have your cameras, which is basically, there's no need to do that. if the city places their camera there, MoDOT should be able to access that camera and verify incidents or use it for their purposes. So this is one reason why we had to share this data. We had to find a way to share data between these data sets. And MoDOT sometimes had data that the cities didn't have, and the cities could use it. So by coming up with a framework that basically helps all of them to come to one place and get the data they need was very relevant. And sometimes what happened is the cities may be talking to like consultants, while MoDOT has their own legacy system inbuilt, which was built like in the 90s. It's so difficult for them to migrate out of that mode. So it's really clunky and it's very difficult for them to talk to each other. But then by coming up with a platform that helps them integrate all their data sets and also provide them with software and hardware that they can share, one, it reduces the cost of data sharing, and it also helps them to achieve the same goal. So data warehouse, which is the first part I wanted to talk about, what we do is we basically connect to all the different data sources that are coming from St. Charles, those that are coming from MoDOT, all these data sources, and then we connect them, we conflate them or integrate them. So now the reason is, for instance, if there's an accident, so the accident data, let's say MoDOT gives you the accident data, tells you there's an accident. And then St. Charles has the weather data. Basically, they can tell you how much snow was on the ground, was it freezing rain? So St. Charles can provide you that data. MoDOT can't. If you mix this data up, you're able to know what actually caused the accident. Okay, so we always have to integrate the data sets. If there is a queue, a congestion on, let's say, a particular intersection, we want to know, was it because of an accident? Was it because, what was the cause? By integrating the different data sets, you're able to do that. Okay, so that's pretty much important. So every data set is connected to the other data set before we pull it into our data warehouse. And this is, for instance, one benefit that I just wanted to show. You could look at what's the riskiest highways in St. Louis during inclement weather condition. Okay, so there's weather data, there's crash data. You want to figure out which roads are pretty much risky when it snows or when there's freezing rain. And pretty much I was able to query this out on the fly by just selecting inclement weather, and it basically sorted out which roads, and these were the 3 top roads that came up in the St. Louis region. So there's so much you can gain by sharing data and then integrating it. Now, there are challenges, of course. As I said, the attributes that, because there are different vendors, the attributes that usually comes out may be different. So generally we go for, instead of, so it's not like, oh, I have a column here called street name, and I have another one in this data called street name, so I can merge it. No. Sometimes one data set will have street name, the other doesn't have street names. So generally we look for, if you have tables that have unique columns, awesome, you can join them. But sometimes you have to basically just do spatial conflation instead. And then sometimes the way the texts are named, for example, there are 3 ways to name St. Louis. You can go with St. Louis. You can go with Saint as in S-A-I-N-T Louis, or St. no dot Louis. And then there's so many variations. So for us, in these cases, we do what we call text matching. And so we match the text to see which ones have the likelihood of it being the same. So that's an ML, machine learning approach that we use there. And then sometimes once you integrate the data sets, they get so large. You have 2 data sets, when they sit on themselves, by themselves, it's fine. But once you integrate them, they get exponentially higher, bigger. So we have to figure out ways to store such data sets because they get really huge exponentially. And if you don't have a smarter way of storing such data, it becomes really difficult to actually access or process anything out of that data. So what we do is we come up with we have an architecture that we use. So instead of storing the data on just one computer, like one big massive computer with a lot of space and memory, we don't do that. We take the data and we break the data into chunks, small chunks, and we spread it across a lot of computers. The reason is this. If I ask you to open a 1 GB file in CSV, it may take you some time. It may take you a while. But if I broke the 1 GB file into 10 100 MB files, and I put it on 10 computers, the 10 computers can open the 100 MB files much faster than it would take one computer to open a 1 GB file. That's basically what we're doing. So as long as I have a lot of computers, which with the advent of the cloud, you can really scale. You can have as many computers as you want. You can really spread these data sets across all these computers, and that makes it easy for you to store the data, and also it makes it easy for you to retrieve the data. So even if I have a really huge data set, I can break them into small chunks, spread them on a number of computers, and that makes it easier for me to access it and process it. So that's kind of the main architecture. We do have GPU databases that's usually used for machine learning, but also we use it for visualizing data. It helps us to visualize data much faster. So once again, this is the plan. You want a data warehouse, you have a place to store data, and then we have a place to download data. Okay, so, and this I'll probably rush through this. Generally, we have a web interface. So if you want historical data, you can go and download the data. And then we have an API, which is just an interface that's used to, if you want real-time data out of the platform, you can use that to pull that data. And so this is like one example interface we have that these agencies can go to, and they can filter the data, query the data. The most important thing with this is it's pretty fast, because of the classic computing we're using, because we're breaking things up into chunks and distributing them on a bunch of computers, it's so much faster to download data from the system. Now we have to do this because it's really the systems that we have existing were so slow. Like sometimes if you wanted data for just like Missouri for a year, it will take you so long, so many hours to get that data. So we had to come up with ways to make things faster in this case. So that's pretty much your data warehousing and the data download. The one that we usually emphasize most is being able to analyze, look for trends, and visualize the data right in the same place in the browser. Because for data download, we usually advise people against that. If you downloaded a file that's like 100 GB, what are you going to do with it? So what we do instead is we provide a way to visualize the data in the browser. And it could be really huge data sets that we're visualizing, but also it helps you to integrate. You are visualizing integrated data. So it's not just crash data, but you have crash and you have another dimension where you have the weather. You have another dimension where you have like the roads, the geometry of the road and all that. Okay, so visual analytics is really important. It's not just visualization, but it's also you're doing analysis at the same time. There's this workshop I went one time and they said big data without machine learning is just lots of data. And I totally disagree with that. I think data can explain itself in most cases if you can visualize it well, if you have a good way of visualizing the data. So visualization is really a really key point when you're trying to share data. So what do you have? I have here is data, crash data that's integrated with weather data and then road geometry data. So here you can see the whole full map of Missouri and where all the crashes are happening. So this is between 2012. You can see it's from 2012 to 2021. We've had about 1.4 million crashes. Almost 9,000 people have died, which is pretty sad. And you can see the counties that are usually having most of the fatalities: Jackson, St. Louis City, Greene County, those counties. Now, what happens is once this graph, this map is interactive. Okay, so as you zoom into certain areas, all the other plots around will change. All right, so I'm going to go ahead and have a click. So you will notice I'm going to zoom into the St. Louis region, and the number of crashes will change to reflect how many crashes we had in the St. Louis region. I'm zooming down. You can see all the trends by day of week. And here I'm going to select pedestrians. I just wanted to look at pedestrian crashes. Everything updated to pedestrian crashes. You can see all the pedestrian crashes we've had over the years. We usually have more pedestrian crashes in October. generally just because of, and I probably want to try to go up. I think this is going too fast. I'm going to go back a little bit. So we usually have a lot of crashes in October. I'm sure you know why. Pedestrian crashes, Halloween, especially around the end of October in the St. Louis region. You can of course see from the map which areas we're seeing, but there is just one notorious road. It's called, I think it's MO15, 115. Yeah, it's notorious for pedestrian fatalities. So this is pretty much and this dashboard, and some people call it dashboard, integrates also the weather data. It helps you, and you can basically play between the two. So you can look at crashes that occurred within certain during certain weather events, and so on. Now, this is one tool which is also integrated. So in this case, for the maps, the bubbles you've seen on the map is pretty much the locations of crashes, and the color is basically how it impacted mobility. So when it's red, it's basically saying vehicles have to slow down a lot. And then we have right here the type of weather condition that was existent. Now this data has more dimensions. It has like it was the temperature, how many vehicles were there, what was the queue length, and so on. So for this, I just selected 270, and I pretty much looked at which locations are usually prone to rain, light rain. And as you can see, so you can look at what the delays were, what the queue lengths were when the accidents happened, and so many different dimensions of the data. Once again, this is in the browser. I mean, each agency has access to it, and they can look at their respective district, their respective areas, and the data is all integrated for them. They don't have to download data and then go do this. It can all be done in one ecosystem. Now the visualization is pretty fast, but it's challenging because what you're doing is you're not just visualizing data, you're also analyzing it. So whenever you click on a particular attribute, everything is computed again, recomputed, and the summary statistics is given to you. Okay, so you're not just visualizing, you're also doing computations. And that's where the GPU database that we have, that's where it comes in. It's really fast at making computations, and it improves your speed at doing visualization and analytics at the same time. There are some challenges we faced. Privacy is an issue. So sometimes data, when it's on its own, when you have your own data, it looks like, oh, there's no harm with this data. But once you integrate it with other data sets, you really have to relook at, hey, by integrating my crash data with insurance data, with demographic data, am I still keeping people's information private? You could be, as you keep integrating these data sets, you could actually result, there could be some privacy breaches. So that's one area you want to actually look at. Integrity of the data. So once you start integrating data, you start realizing, hey, there was nothing going on this road. For instance, you integrated your crashes with your weather data, and it's like, hey, the speed here was fine. There was nothing happening on this road. Why do we have so many crashes? And sometimes it may start revealing some integrity issues, because once you integrate the data, you're able to see trends that you can say, oh, I understand this. And then there are some trends you're like, no, there's no way this should happen. So there could be some integrity issues. And so sometimes people want to back out from it. And once you integrate the data, you keep asking different questions. Like so many questions come to your mind. And sometimes some agencies don't really want that, because it's as if they are, it puts their data to shame. And of course, there is this ego of, hey, this is my data, I don't want to give it to you. We purchase it. We just want to be known as the people who have this data. So that's another challenge we usually face. So the agencies have to come together. They have to understand the importance they can all get from sharing data before you move forward. So pretty much I've talked about the 3 components of this framework, and the last part, which is I hope I can do this in 5 minutes. It's the AI part. Now, of course, I'm sure all of you have heard of ChatGPT. AI is booming around this time. Everyone is seeing the benefits of using it. Of course, some people are also getting angry because it's breaching some rules. I mean, if I was an artist right now, I would be so mad because the art that AI can generate right now is just crazy. Although it's basically stealing other people's art. I hope we can actually resolve that problem. But we've gotten to a stage where AI can really support us in so many ways. Just a simple summary. It's usually generally a black box model. It's just a model that will learn features from whatever you feed it. And then it will be able to, once it learns enough, it has enough information, it should be able to tell you whenever it sees that that data. So if you feed it a bunch of dogs, it should be, once you show it a picture of a dog, it should be able to tell you that. A cat, a car, and all that, it should be able to do that for you. But there's a process of learning, which right now it's much straightforward to do, which is very simple code. As a matter of fact, you can actually ask ChatGPT to create some code for you when it comes to, if you have any problem, like if you know the model you want, you can actually ask ChatGPT to write most of these codes for you, and it will write an ML model for you to run. Just the most important thing, though, you have to realize with AI is if you put in junk, you will get junk. That's pretty much what it is. So it's always important to make sure that the data you're putting into the model it's verified, and I think that's where the human comes in, to make sure that it makes sense. It has some relation to what you're looking out for before you actually build a model with it. Now, when it comes to transportation, there are so many problems we can solve with it. I'm just going to tackle 3 today. One is crashes. Can we detect crashes when they happen? Can we actually tell where crashes may likely happen? That's an AI problem. When you go to in St. Louis, MoDOT has an office called the Traffic Management Center. They are constantly looking at video cameras and trying to see where crashes are happening, and then trying to call for first responders to actually come to your aid. Okay, so you have people actually sitting there looking at cameras all the time. This is an area where we can also use AI or machine learning, and then even just data collection. It's very expensive to collect data, but with AI and then using simple devices like mobile phones and others, you can collect so much data that's rich enough to help improve our transportation system. So the first one I'm going to talk about is predictive analytics. We're trying to predict the risk of a crash risk on our roads. Pretty much, that's how I summarize it. Now, the 2, before you even build a model, there's a need to know if there's some relationship between your data sets and what you're looking for. So on my right side, I have crashes, and on my left side, I have accelerations. So accelerations I get from the connected car data. So connected car data will tell you when people are hitting hard on their brakes or when they're speeding, when they're accelerating. Okay, if you look at these data sets, these are 2 different data sets, and yet there are so many correlations between the 2. If you look at the red box on the left and the red box on the right, they look very similar. The patterns in the yellow box or the orange box, the same. The one in the white, and other patterns you can see. Now, you'll be surprised to know that the crash data is for 10 years, and the acceleration data is for only 1 week. The data sets were not collected at the same time, different time horizons, and yet you see those relationships. Now, this tells me that if I have my acceleration data, I could be able to predict where crashes are likely to happen. Okay, so these are things you want to look out for before you even try building a model. Make sure that there is some relationship. Are these data sets explaining what I actually need? So we usually use the hard acceleration data together with like history of the crashes, what speeds we're observing on the roads, where the traffic is. Okay, so the counts. And we look at queues, we look at weather, and of course the hard braking or acceleration data. And then what we do is we put it through a machine learning model, and we're able to predict the crash risks. So this is, for instance, a crash risk prediction for a day. I hope it's okay. Yeah, so at 12 a.m. you don't see much. And green means the risk is low. Red means the risk is pretty high. And so as 8 a.m. we see more predictions, 9 a.m., 10 a.m. goes down a little bit. And so throughout the day, we are predicting where we think crashes are likely to happen. And now the goal is we give this to the highway patrol. The highway patrol takes this data. So every hour they look, we have a prediction for the next hour where crashes are likely to occur. And then they drive to those areas. And usually they will put their flashes on, the lights on, and try to figure out a way to minimize the risk. That's basically what the goal of this is. Minimize the risk so that the crashes do not happen, because this is predictive, right? It's been good at detecting the areas where we think certain types of crashes will happen, like people hitting rear end crashes. And this is still under evaluation, but that's pretty much the goal, to support highway patrol to be able to curb some of these. This is another area. So we basically have a machine learning model that will basically go through the CCTV cameras and will tag them. Hey, this camera has a snow, this is congested, there's a crash on this one. It will count, and then it will feed this information to the traffic management center. And then they will be able to then use this data to respond to events that are happening on the road. So generally have something like this, a front end, and they can search different types of events. So they can look at congested scenes, they can query that and be able to select, look at the camera and see what's going on those sections. I'm going to rush through this a little bit. We also use it for data collection. So generally, and I hope you've encountered this before, you sit at an intersection and you're there, you feel like you've been there for so long and it's not turning green for you. Most likely because it's due to the fact that that signal has not been retimed. It was probably timed like 5-10 years ago, and traffic patterns have changed, and they did not count the movements to know that, hey, your turn needs more green time. So we can use AI to do this. You basically count the vehicles by direction and then use that to retime the traffic signal. This is now this is a little bit separate because this is dealing with pavements. But AI, because basically in this case, we use AI to basically detect the cracks that are in the pavement and then rate the pavement condition. The reason why we did this was, so generally what happens is, to be able to allocate money for reconstruction of a road, we have to do service. We have to see what cracks are on the pavement, potholes, measure the length and the width of the cracks, and then we allocate money for it to be reconstructed or those potholes to be filled. Now, generally, you have people doing this. You have manual service. So what we did was to use AI to do that. We had an interesting case in Kansas City, which I wanted to show you. Let me actually use my pointer here. So this is the data, generally the KC people had. It's just potholes. So these are locations of potholes that they had. You could tell there were so many potholes here on this side of Kansas City. If you know the demographics of Kansas City, this is generally high income area. This other area is really low income area. Now they had an app where if there was a pothole, you could report it through the app, right? So of course, if you live in a high income neighborhood, yes, a pothole is a problem. If you live in a low income neighborhood, no, that's not one of your problems. So they kept getting low rates in the low income areas, which also meant that they were not trying to fix these because there aren't as many potholes in a low income area. They will always go to the high income areas and fix those potholes as soon as they are reported. So what we did is we basically deploy our app. It's a phone app. And then just went around. Within 2 days, we resurveyed the whole place. And in fact, there was so many more potholes in this area than that area, and they were in worse conditions than the high income neighborhoods. So it's not just predictive, but it can also help improve our data collection. And this was a dashboard that we built for them to do that. Now, so in a nutshell, trying to end on this, I think we've gotten to a point where transportation data is very rich. We have data at a really high resolution. It's really important these data sets are integrated. Without integrating them, you can't do much out of it. When we integrate them, then we can be able to make use of it and share it with these agencies. That's one way we will be able to confront the key issues of safety, congestion, and equity, and all these challenges that we have in today. Ultimately, you want to democratize data. You want every agency to be able to access the data they need. You want them to be able to have access to the hardware that's shared among across institutions. There's no need for everyone to have their own cloud system for processing data sets that can be shared across different agencies. And software also, I think software should be shared while keeping privacy at the center of these. I think it's key. Anyway, I think that's where I will end, and I will entertain any questions.
Thank you so much. Yeah, this is so much to think about. I just wanted to point that there is a question in the chat asking, is there a place we can view and download some of this data? So I guess who has access to the data you're discussing?
Okay, let's see. So there's a process. You will request. So the agencies involved want the data to be kept between the agencies. However, you can send a request, and this is and I'll probably put the website in the. I'll put the website in the chat later, but you can request access. I'll usually just ask what you need the data for, and then based on that, we can grant you access for a time. But yes, there is just a process to get access to the framework so that you can download data.
Other questions out there?
I know that I'm one of the people hosting, but I have a question. I thought this was super interesting. And I was just kind of wondering, like for the predictive analytics piece,
yeah,
how accurate do you find AI data to be for that?
Yes, that's a good question. So not all crashes can be predicted, right? For instance, if I'm driving and it's because I'm distracted, I get into a crash. There is no way I can predict that because I don't have access to your distraction level. So what the predictive analytics is, what it's doing is, are there risky situations on the ground? So for instance, if it gets data and realizes, hey, there is freezing rain. Hey, there are a bunch of vehicles here that are hitting their brakes hard. Then it's like, ideally, this could create an accident. So it basically flags that location as a high-risk location. What I've noticed is it's good at predicting rear-end crashes, where there's a queue and people hit at the back. Like they don't realize there's a queue and they're speeding, and then they hit it. So it's really good at predicting that. It's good at predicting runoffs. Basically, you skate off the road and then you fall into a ditch somewhere. Locations where those can happen. It's because it has good weather data. And because it's also dependent on the data we're using. The data we're using hard brakes and hard accelerations. So it's only going to be good at predicting data. I mean, events that these data capture, and not events. So events that your data cannot capture, there's no way. So what we've noticed is the predictions are good on the freeways. Outside the freeways is it's usually not off.
Thank you.
Yeah.
I have so many questions. I want to focus on one of the last things that you said about data equity. You didn't frame it in terms of data equity, but it was about data equity in terms of like, there are potholes here, but they're not reported as a problem,
Mhm.
even though there may be potholes there. Can you speak more to that? And that's really interesting as we look at crowdsourcing as a source of data. Like, maybe it is data to some, maybe it's just nothing. Maybe it's something you shrug off, like that's a thing we just expect. But in high income neighborhoods, this is a problem. This is a pothole. It's a problem. Can you speak more to what you found?
So it's and generally I understand what the agencies are trying to do. They want, especially for potholes, if you don't chase the potholes, it will completely destroy your road. So I don't know if you've noticed, immediately after the winter, you see potholes all over the place. So their goal is to chase these potholes, and the best way is for people to report them as soon as they appear. So I don't think they were. I don't think they thought about the implications of that. But yes, it is just a thing with low-income neighborhoods. I think when they showed us the data, I think it was just my gut feeling was, yes, I can easily tell that this data will be biased toward low-income neighborhoods. Now, while it's generally they won't report it because it's not your problem. I mean, because they have other problems to think of. For the agency, it's a big issue because then their roads get deteriorated much faster, and you're going to spend way much more money to fix those roads. So it was eye-opening, I think, and we actually did the survey in 2 days. It was much faster. We got way much more data than crowdsourced data. And so the goal was, could you actually just let people use this app and then just as they drive, capture this data instead of just letting people report it through your own app? Have an app that will basically record it automatically, take the person out of the situation, and then automate the process with the AI. Yeah, so I thought that's an good implementation or use of AI in that area.
So I'm definitely interested in hearing other people who are in the space, examples of similar types of, data sharing or AI applications. But before we do that, I just want to give one more chance for any questions specifically for Yao around this application, these applications.
I have a quick question. How many people were involved in this process from the point of getting access to the data through visualization?
Good question. So we have, let me see. So we have a backend group, which is, I think, 3 people. And we have a front end that's basically designing the websites and providing for people to interact with the system. That's, I think, 2 people. And then we have the machine learning group, which is 2 also. So 3 to 2, 7. Yeah.
Thank you.
Yep.
Any other questions? Paul, I thought I saw you coming off mute.
Yeah, I had a quick question about how like non-institutional folks can get access to this. So for instance, I have friends who are involved in a like bike and pedestrian advocacy organization in town. It's kind of connected to the city and kind of isn't. But I'm curious about how, this sort of information I think would be very valuable in helping them identify like where points of access should, like how do we mitigate certain things? And so I am sort of wondering, some examples of how this information has been used for advocacy purposes, which may run into points of tensions with some of the local governments and others that you are serving.
Which, no, that's a really good question. And I think usually that's where, and I think that's why initially they just wanted to keep it amongst themselves. Because there is so many points of contention. I mean, especially, so I did present this at one meeting where, and I think I showed some key routes where that basically where we're seeing crashes, a lot of crashes during inclement weather. And someone pointed out, yes, we know they never put salt on these roads. That's why this is happening. And some legal people were like, this could create issues. And so MODA doesn't want to have the issues with, I mean, the legalities surrounding this. But I definitely think this will be opened up with time. The only thing is they want to make sure that whatever is being reported is concrete and they have the best explanations to give for what is happening before they actually open it up. Because that's the goal. The goal is basically to open the data up to other constituencies. But right now, you go through an approval process. So you send an email to, I mean, you go to the website, you can register and everything. And then I'll basically ask a few questions, send it to St. Charles County. There's someone there who actually say, okay, approve the person, let them in. But I know if advocacy groups, I'm not sure. I think that's where it will trigger or something. Yeah.
Yeah, I mean, in this case, it's like, yeah, not necessarily, it's not always antagonistic. It's like a committee of the city, right?
Yeah.
But they are technically independent. And I think the job is to like think about how, we can do more, pedestrian and, bike friendly transit. And so, yeah, it's just sort of like thinking about like data democratization while also thinking about institutional context, and like very
Exactly.
much am not advocating that like, there aren't some sensitive things here that need to be contextualized so they are appropriately understood and pushed upon. But like, yeah, just wanting to see if like in what circumstances it would be appropriate for an outside group that was not, local government, who may or may not like, push for things that go through the normal channels of process. I think that's where this information starts to get really interesting, rather than just like being filtered through institutional lens, which have its limiting points.
That's a really good point. And I really hope, I think that should be the goal. And because that will also put the agencies to action, because rather than just looking at the data, they will know that people see this and they will take action at addressing some of the issues that are in the data. I completely agree with you.
And I think that is a good segue into, since we just have a little bit of time left, to think about how do some of these themes come up, not just in this example, but in others who are in the space, thinking about data sharing or data collaboration in the social sector. So just curious if anybody has other examples of the same kinds of themes coming up.
Yeah, we'd love to hear from you all. Just thinking about how we can use AI in, we put broadly the social sector, but feel free to apply it to your individual area of interest. So yeah, we'd love to hear from you. If you can come off mute and tell us how you have been using it or how you've seen this type of AI technology being used.
Okay, so I'm going to come off mute, but this is a question directly back to, I'm sorry. These were 3 agencies that you worked with, and I knew how difficult it was even to get these 3 to work together. How easily do you think you could, like, let's say, I don't even know how many jurisdictions are in St. Louis, so many entities. Let's say 40 of them wanted to, I mean, how quickly could you ingest all of that? How easy is it to even ingest all of that, even when everyone is collaborating?
I think we spend most of the time actually doing that. It's the most time consuming part.
What is the most time consuming part?
It's where the data is right now. first of all, most often I had to basically go to the data centers and pull data from there. There wasn't an easy way to exchange data with me. And two, the data sets, they don't talk to each other. It's like, if you give me a crash, if you told me a crash happened and you didn't give me a lat long and you only gave me, oh, it happened on I-70. How on earth do I know? I mean, how useful is that to anybody? So going through all that process and filtering their data, knowing what they also need. So it's not just because you have to build a dashboard, a visualization platform for them. So it has to be something that you know they will need always. So you talk to them and understand their pain points, what they really need out of their data. And then after that, once you know you have their data sets, once you know what they need, the integration process and storage, I think that's pretty seamless. But it's the kind of data they have now, the formats they are in, the accuracy of the data. You basically have to remove so much out of it because they don't make sense. They don't add any value. And I felt like that's what took us so much of our time.
Right, I could totally see that, and there are more questions coming in the chat. Is this a space where AI is going to have some trouble? Right, I'm already thinking about how, like, as a public transit agency, we're using some data, and if I was an objective outside researcher, I'd be like, why are you doing that with the data? You know what I mean? Like, so is that going to be like a difficult tie to unknot?
Oh,
Where
it's
can AI come in?
the problem is that AI depends on that data. So in most cases, for instance, when I was building the crash risk model, I did not use any data before 2019. It was just the inaccuracies prior to that was just too much. And so then if you build a model based on that, then you're basically, the AI model doesn't really do a good job. And in most cases, I think some of the data sets we're getting now are much richer and better. So instead of focusing on what we have had in the past, maybe improve on what we have now. And maybe in a year or two, we will probably be there. And for most agencies, I think that's what we had to do. An exception of the crash data, I think for a lot of the data sets, we basically wiped it off. It was just not useful.
Thanks for that. So I saw in the chat there that Michelle mentioned that they're using AI in order to do note-taking services during board meetings, and how AI is being used in the grant-making space. I think that's really interesting. Michelle, I would invite you to come off mute if you'd like to and tell us a little bit more about any other places y'all are using that, and what are your impressions of it?
Yeah, and I am so sorry. I'm grateful that this is being recorded so I can go back and get the rest of the content. But we had a meeting where we had some note taking happening for us during it go long. But I think this is something that we're seeing. So Philanthropy Missouri is an association of grant makers for the state of Missouri. And we have peers across the country that are either geographic or they focus on a particular topic, like grant makers in aging or health. And we are seeing a lot of discussion around this. We've picked our summer book club book is The Tech That Comes Next. So we're seeing our members want to engage and learn more. And I'm not sure that there are trends yet. There's a lot of discussion. So lots of discussion about what this may mean about the quality of data around equity and justice lenses in data, which I'm sure you all dove into in your presentations today. So I look forward to learning more there as well. So not much more to add to that, unfortunately, at this point, Sarah, but we're listening and we're trying to make sure that that no one is caught unaware, and so that people are feeling included and able to converse on a topic when they don't have a background that is particularly tech heavy, right, or data heavy. So a
Mhm.
lot of folks in the philanthropic side and even in the social sector overall probably wouldn't describe themselves as particularly fluent in this space. And so how do we help bring folks in and help them gain access to the benefits and avoid some of the pitfalls if they're not conversant in the language?
That's a great point, Michelle. Thank you for sharing. And
Can
I
I,
noticed,
oh, go on, Sarah.
nope, go ahead, Paul.
Well, I was just gonna add real quickly, like I think, you know, the work that you described, Dr. Yeah, like the transportation data, especially sensor-based data and like data that is tracking movement, like I think is like tailor-made pretty well, you know, to fit into, you know, AI models or machine learning models in ways in which like, yeah, like a crash is a crash most of the time. I mean, some folks raise issues around like potholes not being reported or other people not sourcing data, and that's always going to be a concern. I do think in the social sector as a whole, though, much more often we're hitting these challenges of like data sourcing and data standardization that almost necessitate what people call like human in the loop, you know, AI processes. And I see Kevin Stanley is on the call. We're working a little bit with Kevin and his team at the Unity Foundation on an AI oriented effort around like social service coding and taxonomy matching. In which it's like there's data, you can use natural language processing and otherwise to like point out some of these standard terms and, you know, terminologies. But to your point, Michelle, there's like a lot of peril in cutting people out of a process of reviewing things like how someone's social needs are codified, that I think in nonprofit social services, health services, like needs to be much more of a point of emphasis than I think maybe in the transportation space, in which it's like, you know, a lot of times it's pretty clear what is happening, or just the amount of data, you know, means that some of the things are kind of evened out across the noise. So I just wanted to share a little bit of like how we've waded into the AI work and really underscoring that I think in human-centered, like complex, people-oriented stuff, like making sure that it's like, this isn't about replacing, you know, data folks and what they do. It's about elevating the work to be more specific and like removing some of the headaches, but not removing the decision-making.
Yeah, I was going to point to that, in the chat, David W. mentioned, you know, we need the data accuracy oversight to make sure that we're not, you know, putting bias in and, you know, getting bias out. So similar point. David, if you have anything you want to add to that, feel free to join in.
In the pre-call to this meeting, when Yao revealed to some of us about this, like every 3 seconds, if your car is connected to the internet, it's capturing your acceleration and braking and so forth. We were all kind of like, you know, I think depending on what fields you come from or whatever, you know, we kind of might go to the pretty quickly to the peril and the privacy issues and the like, where could this go? And, you know, we're like, well, who does own that data? Was it privately owned? Well, what about insurance companies? Like some of those considerations jump right to our minds. And I agree with Paul that like, depending on what area you're coming from, it is important to jump in and see that and think about and put those things forward and front and center. And it's also a challenge for how to think about AI in particular, machine learning, like in useful, you know, how it can be useful and not just, you know, look at it all one way, but really foregrounding any kind of privacy and ethical considerations and bias that can be just expedited by being programmed. And
I was just looking at the second question of what are the benefits and risks you've experienced or observed. Obviously, what Dr. Yao is talking about is a very complex use of AI, which is really interesting. I read an article though about my alma mater that used a AI technology to write a letter in response to a university shooting, and it was not, I mean, it was fine, but it was like there were some issues there, and they left like created by, you know, I think it was like ChatGPT on the bottom, which is just horrible, because they're responding to a, you know, really emotional and sad event with an AI software. And so I think that goes back to the point that both David and Paul brought up, which is like how can we make sure that we're not losing that human aspect in all of these types of interactions?
Uh, yeah, you had mentioned before the call that you were, you know, everything's catching up, right? You had been working in the AI space for quite some time. What has caught up? Like, what are you grateful for, and what are you concerned for?
One is I think people now believe in it, that it works. That used to be our biggest hurdle.
Well, the people didn't believe in it. They thought it was.
Yes, they did not. It was people did not believe in it. You will never get a grant for writing an AI application. Never. Nobody will give you that.
How many years back? For how many years have you been?
I started working in AI during my PhD. That's like 2008.
Okay.
My advisor had been working on it in the 90s.
Wow.
And until 2013, there was nothing. It was really so it's been pretty recent, and then it basically showed up. Now, of course, the models have gotten way more accurate. The accuracy of the AI has really showed up. What I'm worried about, so of course, I mean, it's going to displace a lot of people. I know we say it's going to create jobs, but it's definitely going to displace a lot of people too, because especially those who are like, I mean, if you're young and you're now going to school, fine, you can now redirect what you get into. But if you're in your 40s and there isn't much you can change, so it's definitely, there are a lot of people whose life will be displaced. I also think of how people use it. It's becoming, so right now I can go on ChatGPT and code a machine learning model, an AI. I can do that. So everyone has access to it. But that's to the restraint, like what are you using it for? We don't have any ethical kind of guidance on how to use AI. The way it's powerful, it can do a lot of damage, especially if you live in a country that that really doesn't care what you do with it. It can be, I think it can be really dangerous. And I've listened to a lot of like some of the Godfathers in this, and that's one thing they are pretty much worried about. I don't think it's really a big issue. I mean, I don't think it's that difficult to mount some weapon on a drone and direct it to a particular location right now. I don't think it's that difficult to do. That's how dangerous. That's why I feel it's yeah. Those are some challenges I feel like I'm afraid of.
That is a challenge.
Yeah.
So then why do you believe in it? What's the good, the overall good that you, I mean, I see a lot of good. I could go forever about it, but you please tell us.
I think it could be an equalizer. There's so much I mean, I don't know what to call it, inequity. I think it could kind of make, especially places where countries that are struggling to make it, especially in agriculture, precision medicine, on all these areas where, I mean, the advanced countries for so long have been able to make so many investments and prosper because of it. I think AI could, in those countries, help to equalize that, also give better health for those countries. Agriculture, precision agriculture, better yield. I feel like those in transportation. In the other areas, military and those places, it's just too dangerous. So I feel like there's so much benefit if we can find a way to, and I don't know how we will even find a way to do that. But if we can find a way to control access and use, but the problem though is AI has been developing now because we opened it up. Everybody can contribute. So right now, if I'm doing something, I can just go to GitHub, put my code there, and people can support. There'll be a lot of people supporting me to build my dream. So, and that's why, I mean, OpenAI was basically a lot of universities contributed to it. I don't know why Microsoft all of a sudden thinks they can make money out of it, but that's how come these things are growing that fast. Like, but that also exposes, because anybody can use it, anybody has access to the code, anybody has can do whatever with the AI, which is dangerous.
Well, I'm just going to say to be continued, because this is a conversation that I think we have a lot more to say on, and I know we're at time. So I just want to respect everyone's time and say thank you to everyone. Thank you, Dr. Yao, for this very thought-provoking conversation. And we look forward to continuing. And we're going to do some more data deep dives. I've put something in the chat that has like our survey, so please fill that out, and you can also suggest possible topics for future data deep dives. So thank you all for being here, and hope to see you again.
Thank you.
Well, thank you so much. I'm so glad you were our first. It was so thought-provoking. We have many more conversations to have, so thank you very much.
Thank you for
I look
having me.
forward. Yeah, I look forward to it. Thank you.